Hello friends, I'm Ram Lakshmanan. So I'm the architect of Ycrash. So in this session, let's talk about the performance impacts of Java virtual threads. See, before you get to learn the performance impacts of Java virtual threads, you need to understand the architecture of the Java virtual threads. For that, I've given a separate talk on how to, it's an easy introduction to Java virtual threads. You may want to watch that first before watching this video clip, right? That link is given in this description, okay? So now let's talk about what are the performance impacts of Java virtual threads. Friends, let's discuss the performance impacts. That is to see whether the Java virtual thread, is it really lightweight, right? From these four perspectives, from memory, what is the performance impact of virtual thread to memory? What is the performance impact of the thread creation time, the CPU consumption, and whether there's any difference in the exit, right? That's what we'll discuss. Okay. First, let's discuss what is the memory impact, what we are going to get by using the Java virtual threads. Okay. So friends, to facilitate our discussion, here I have put together two simple programs, very simple programs. So let's look at it. Here I'm calling this program as a Java, it's a platform thread demo, right? If you see what I'm doing here I'm creating a runnable task, right? Here I'm not doing much. Here I'm just putting this thread to sleep, right? So I'm creating a task and putting it to sleep. But in a real world, a thread wouldn't be sleeping like this. Actually doing some real execution, and then it would be waiting. Waiting in a way means it is actually sleeping only, right? It is not doing any work, right? To simulate that, I put to sleep. But along with it, it's going to do some more other tasks. But I'm just mimicking a simple program. And now look at it in this main method, which is the entry point to this platform thread demo class. I'm creating like a 10,000 threads. So here I'm creating a 10,000 threads, and then I am launching them. I'm just starting them, right? That's what I'm doing, right? This is that program. And now here is another program where what I'm doing, it's called a virtual thread demo. In this thread, the task, which is very similar to what we saw in the platform thread demo. Here I'm just creating this task, just putting it to sleep, right? I'm putting it to sleep. That's what I'm doing. And here, instead of launching the platform thread, if a difference, I'm launching it as a virtual thread. That is the only difference I'm doing. So now I'm going to run both of these programs to study whether there's any difference in the memory impact. That's what I'm going to be doing. And I launched this program in an AWS T3 extra large machine, right? That's what I did. And one thing, I launched this with a thread stack size to be 1 megabyte, right? 1 MB, but some applications may have the thread stack size to be much bigger. Someone may be having it as a 512 kilobyte, right? It might vary, but I just took as 1 MB. When I launched it, only difference is one is virtual thread, other is a platform thread. That is the only difference. You can see there's a top command which shows the memory and the resource consumption that all the processes running on the container or on the device. Here you can see, look at this, friends. A red one is the platform thread demo, right? This red one is a platform thread. It consumes 14.3 gigabyte. And the other one, there is this green one, is basically it consumes only 4 gigabytes of space, right? So this is consuming like a 10 gigabytes more. That is the platform that is consuming 10 gigabytes more memory. Why is that, right? The reason is, friends, 10,000 threads, right? The program creates 10,000 threads. Each thread occupies 1 MB. So it means 10 GB more. That's why this is consuming, the platform threads are consuming 10 GB more, whereas virtual threads are consuming 10 GB less. Because when a platform thread, irrespective of whether it is actually executing some job, waiting, it's going to still consume that entire thread stack size. Whereas the virtual one even actually executes some lines of code, right? In this case, it is not executing. The thread is basically sleeping. Sleeping means underlying it is waiting. So that's why it doesn't consume that much memory. So you can see clearly if virtual threads to consuming less memory. So especially when you move to virtual threads, and if you have a lot of virtual threads, there's a good chance that your application can see a relief in the memory, right? So now let's talk about the thread creation time, whether there's any difference in the thread creation time, right? To do this, here I've created this sample program plus a platform thread factory. Here there is a runnable task, right? It just says I'm printing hello and platform thread. And here, what does it do? Here I'm creating a platform thread. I'm creating a 10,000 platform threads, right? I'm then saying start. Okay. And now here is this virtual thread factory. It's the same task, right? I'm printing. And here I'm creating a 10,000. Here I'm creating 10,000 virtual threads. You see, I'm just saying creating a virtual thread. I'm creating a 10,000 virtual thread. That is the only difference. This entire program, this virtual thread program, was able to complete within 91 milliseconds. Whereas this platform threads took 998 milliseconds. That is 10x more. The reason for that is because whenever you create a platform thread, and underlyingly an operating system thread has to be allocated to it. And friends, creating an operating system thread is not a cheap process, because you have to talk with kernel. Kernel has to allocate space, it has to set its configurations, and it has to be given. It's not a cheap. Thread creation is not very cheap. So that's why, because it's now creating all the 10,000 operating system threads, it's take time. That's why you're seeing. Whereas virtual thread, it only, when it has to execute, then it's going to take. So it just now created just as an objects in memory, which is comparatively much cheaper to create. So that's why it is. And friends, don't get too much influenced by this, because most don't create threads at runtime. Most applications, threads are created during the startup time and they are pooled there. So unless your application creates threads at the runtime for every run, then moving to virtual thread will give an impact. Otherwise, you may not see any much noticeable difference, but you need to be aware of it. Okay. And then the next two things from the CPU perspective and the execution time perspective, right? The CPU means CPU is consumed only when your thread is actually executing some lines of code. In this case, even when a virtual thread is executing, underlying it uses a platform thread, right? So in terms of CPU consumption and execution time, you wouldn't see any major difference, because at that point, virtual thread is basically riding on a platform thread. So you won't see much difference in the CPU and the execution time, right, friend? So this is to give a perspective of what is the performance, thread creation time, the CPU and the execution time impact of a Java virtual thread. Then we will catch up with you in another session. Thank you everyone for watching this video clip.